The 11 o'clock class had this test, and so I'm going to work through it for you, and then I'll do the other class in a bit. Okay. L6, and this is velocity time. So L means left, and we've got to do it in 6, and there's 1, 2, 3, 4, 5, 6 gaps. So to do left 6, the width of each one of these is 3. 3 times the left side of the first one has a height of 3 meters per second. The left side of the second one is 6. The left side of the third one is 7. The left side of this one is a height of 12 meters per second. Then 15, and then 16 is the left side of the last one. And this works out to be, let's see, instead of me taking the time, you should be able to do this. It comes out to be 3 times 59, which is 177, and we should put units on this. Now, we're doing, the 3 is a change in time, 3 seconds times, and these heights are velocity, which is in meters per second. So the seconds cancel out, and we get meters as the distance or displacement. Now for the next one, we're supposed to do M3, the midpoint on 3 intervals. So now I have to split this into 3 intervals. So there's 1, 2, 3, and the height in the middle of this is 6. The width of the interval is 6. Width is 6. The height in the middle of this one is 6, plus the middle of the next one is 12, plus the middle of the last one is 16. So that is 6 times 34, which is 204, and this again is meters. They're both trying to find this. They're both trying to figure out the change, not just the distance or displacement, it's the change in the displacement. Displacement's the correct one. If we took the absolute value of all these velocities, then it would be distance. But these velocities are all positive, so it wouldn't make any difference. So if you put distance, I gave you full credit. Okay. Now let's do this next one, which some people struggled with. F of x is 3x. And we're supposed to find the limit as n approaches infinity of the width of the interval times the height added up on, these are the right sides, a plus 1 change puts us on the right side of the first change, from I equaling 1 to n. An f of this means we put this in here, and it's times 3, so we get 3 times a plus delta x I. That's f of this. Now, since 3 is a constant, it'll come out of a summation. So we get the limit as n approaches infinity of 3 times delta x. And then I'd have the sum of this part and this part, which I can split into 2 sums. I'm going to have the sum as I goes from 1 to n of a's plus, and delta x is a constant, so that comes out of the sum, but only in here, not completely out, times the sum as I goes from 1 to n of I. Okay. So this becomes the limit as n approaches infinity of 3 delta x. What's this? It says when I is 1, we get an a. When I is 2, we get an A. When I is 3, get an A. We get an A for every one of these from 1 to n. So that means that's this is A to n A's. And there's a formula for this one. When you add up 1, 2, 3, 4, I is 1, we get 1, plus when I is 2, we get 2, plus 3 plus 4 up to n. So we have 3 delta x times n a's plus delta x times the sum of the integers 1 to n is n squared over 2 plus n over 2. All right, now I'm going to put in what delta x is. That's the width of the interval. So we're dividing from a to b, so it's b minus a, into n pieces, so it's divided by n. That's what delta x is. So this becomes the limit as n approaches infinity of 3b minus a over n, that's delta x, times n a, plus 3 delta x times delta x is 3 delta x squared. And delta x is b minus a squared over n squared. Got to square the numerator and denominator. And that's going to be times this first part, n squared over 2, plus it's this times this, which is going to be 3 delta x squared times the second part. All right. As n goes to infinity, well, these two cancel, so there's no end involved in here. So we got 3a times b, and we got 3a times the minus a, which is minus 3a squared. These n squareds cancel, becoming 1 and 1, and so we have plus 3 over 2 times b minus a quantity squared. That would be b squared minus 2ab plus a squared. And no n's left because they're canceled. On this last one, the n in the numerator is going to cancel one of them, but there's still be an n in the denominator. And when n goes to infinity, this whole fraction will go to 0, so we get plus 0. So we've taken the limit and done some algebra. And so now we just need to do the algebra to clean this up. So we got 3ab minus 3a squared plus 3 halves b squared. The 2 on this one, when we multiply by 3 halves times 2, we get 6 halves, or 3, so minus 3ab. And 3 halves, that will be plus 3 halves of a squared. These cancel. And minus 3a squared plus 1.5a squared is minus 1.5a squared minus 3 halves a squared when I put this one and that one together. And I have 3 halves b squared. And that is what the integral of 3x from a to b dx would be 3x squared over 2 evaluated from a to b, which is 3 halves b squared minus 3 halves a squared, which is what we have. So I got through it without making too many errors. Okay, 3. If I were to draw L6, that would mean I'd go and do 6 of them from 0 to 3. Each one would have to be half wide. So I'd go from the left side over and make a rectangle. From the left height, which is here, over and make a rectangle down. And from the left height over and down. From the left height over and down, down. From the left height over and down. From the left height over and down. L6 would be the area under each of these rectangles. And you can see we're adding extra on. Now, our T6 would go a trapezoid that has a height at each side of the rectangle and make a line across. So this one would be slightly less, but not nearly as much as this one's over. Then we go from there to there, which is really close to the curve, I suppose the extra. And from here to there in a straight line would be something like that. This is way more off than that is from the line. And from here to here, this one's going to have a little bit more than the curve. The L had a lot more. And that would be pretty close, and that would be pretty close. So T6 is a better approximation because, now I could say several things here. I'm just going to state them because from the picture, the L's have a lot more extra than the trapezoids. Okay? Or you could say T6 is better because it would do the average of the under and over, which is also another way to get T6 is to do left 6 plus right 6 divided by 2. That's the same as T6. And if we average the heights from this, how much this is over and how much this is under, how much this is over and how much this rectangle is under, and if we consider those two, they would be really close too. So you could talk about it being the average, which stays closer, or that the trapezoid stays closer to the line than the rectangulars only. All right, so that's what one of those two I would say for this. Now, to calculate the T, you can do T6 equals, and 0 to 3 divided by 6 is 1/2 is the width. And you average the height at the left and right, so that's 6.5 and 6.2. So you could go 6.5 plus 6.2 over 2 plus, and the next one would be 6.2 and 5.5. And we could keep doing that, but all the way to the end, the last one would be 2 plus 1.8. However, it's a lot easier if you do T6 by doing 1/2. We get half of the first one and 2/2 of the second one, so we can just use all of that. So we do 1/2 of the first entry, 6.5, plus the next height, 6.2-ish, plus the next height, 5.5, plus the next height, 4.5, plus the next height, which is 2.4-ish, plus the next height, which is 2, plus half of the last height. Anyway, let's see, 2.4, Boom, 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 boom. Yeah, this is what I did on my key, and when I worked this out, I got approximately 11.875 for the area under the curve. Okay, page 2. So we're supposed to find out, and you got to understand, f of t, f is the inches, and t is the hours after noon. So this says 4 hours after noon, the inches were 6 inches. 6 inches at 4 p.m. That's what this means. This says 4 inches at 2 p.m. 18 inches at 9 p.m. This says this is the change from 2 to 7. 2 p.m. to 7 p.m. We got 11 inches more. So that's the idea with this. And this is from 1:30 to 4, we got 4.5 inches. So how much was there at 7 p.m.? Well, from 2 to 7, there was 11 inches. But we went from 4 to 7. Oh, no, we went 7 exactly. And we don't know how much, we do know that there was 4 inches at 2. So there's 4 inches already. And then from 2 to 7, there's 11 more inches. So that makes 15 inches, not increase, not fell, but that's how much inches there is at 7 p.m. That's inches of snow. B, this says how much fell between 4 and 7. Well, between 4 and 7, 7 had 15 inches, 4 had 6 inches. So 15 inches minus the 6 inches that were there to start with is 9 inches. 9 inches of snow fell between 4 p.m. and 7 p.m. So the integral is a change. So we know that it changed by 9 inches over this time period. Now this wants to know how much was there exactly at 1:30, 1.5 hours after noon, 1:30. Between 1:30 and 4, there was 4.5 more inches of snow. At 4, there was already 6. So at 1:30, it was 6 minus the 4.5 that came to get to the 6, which is 1.5 inches. And this is not a change. This is how much there was. 1.5 inches total at 1:30 p.m. And finally, this says how much snow fell between 2 and 7. Well, between 2 and 7, 11 inches fell. And this is, 7 and 2 are the time, so this is 1/5 hours. That's the change in hours. And we got the change in snow amount, which, if you divide it, you get 2.2 inches in those hours. So this is a rate. This is the change in thickness divided by the change in time. So this is 2.2 inches per hour is the rate of snowfall from 2 p.m. to 7 p.m. Okay. If we have an even function, what it does on the left side, it does on the right side of the y-axis. So if it goes from 0 to 4, and it goes up by 2, the area has to be 2, which means it had to be 2 over here if it's an even function. Then it says from -4 to 6 is 8. Well, we already have 4, so this part here has to be 4 more, which means on this side it has to be +4. So from 0 to 6, that's 2 plus 4 is 6. From 4 to -6, well, from -6 to 4 is 8, so 4 to -6 is -8. And from -6 to 6, we're getting 4 plus 2 plus 2 plus 4, which is 12. Okay, this is the derivative with respect to x of this, but this doesn't have an x in it. But if you take the derivative of something that you're integrating, they're going to undo each other. And so we're just going to get x squared put in and 3 put in and take the derivative. So if this is little f of t, then if we integrate this, it would be, we haven't taken the derivative yet, of capital, whatever the antiderivative of this is, which is not easy, plugging in the x squared minus plugging in the 3. Now, if we got to take the derivative of the antiderivative, it takes us back to this one with x squared plugged in. But if we're taking derivative with respect to x, then we have to take it times the derivative of the inside of this function. So we're going to get derivative of the inside is 2x times back to this function, sine, but we're putting x squared in place of t, so this becomes x to the 4th plus 1. And then the derivative of f of a constant, this is just a constant, so this becomes -0. So there's my answer for g of x. Page 3. Since these are added or subtracted, I can split these up. I cannot factor out the 3 out of the whole thing, but I can factor it out of the split up one. So I'm going to split it first into the integral of 3 over the square root of x dx plus the integral of 7 dx minus the integral of 3 secant squared x dx. Now I can pull constants out, and so then I'm going to get the 3 outside of this one. It's going to be 3, and I'm going to move the square root of x into the numerator, so it's going to be the x to the -1/2. So x to the -1/2 is 1 over the square root of x times a 3, so I haven't changed that part. Plus the integral of 7 dx minus 3, I can pull the 3 out because it's a constant times this, integral of secant squared x dx. To integrate something to a power, there's a power rule that says add 1 to it. which would make this x to the 1/2, and divide by 1/2, which is the same as times 2. So we're going to have 3 times 2 x to the 1/2. A constant integrated is not 0. Differentiated 0. Integrated, it's 7x. And the integral of secant squared is tangent. So this 6 square root of x plus 7x minus 3 tangent x. Okay, we can't pull a 3 out of the numerator because it's not times both of them. We could pull the 6 out, but we can also split this up. So I'm going to split it first. Integral of 3x squared over 6x minus the integral of cubed root of x over 6x dx. So this is 1/2, and it'll come out, and x squared divided by x is just x, so we got 1/2 the integral of x dx. This is 1 minus 1/6 the integral, and this is x, and if I bring it up, it's x to the minus 1. Cube root of x is x to the 1/3. So this would be x to the negative 2/3 dx. So this becomes x squared over 2 times that, so it's x squared over 4, or 1/4 x squared, minus 1/6 times, if I add 1 to this, I get 1/3. If I add 3/3 to this, comes up a positive 1/3. And that's adding it, so it'd be x to the 1/3. But then I have to divide by 1/3, and I have it times a 6, negative 6. So this is 1/4 x squared, and 6 multiplies by the 2/3 in the denominator makes 2, or minus 1/2 in the denominator, 2 in the denominator, minus 1/2, and x to 1/3 is the cube root of x. Some of you use substitution for the denominator. Some tried substitution for the numerator, but you always want to look at these problems and say, is there a way I can simplify this? Like, we took this one and split it up into 2 things. We didn't do substitution. We didn't do substitution here. We just split it up, and then we're able to integrate the parts. Can we split this one up without use substitution and do something with it? Well, x squared minus 4, you should know that that's x plus 2 times x minus 2. Plus 2's cancel. So we have the integral of x minus 2, and that can be split up the integral of x, which is x squared over 2, and the integral of minus 2 is minus 2x. On this one, x squared minus 3x factors to x times x minus 3. So it would graph without the absolute value, would go through here and come back through at 1, 2, 3. Be right side up. So if I want to integrate from 0 to 5, the absolute value of this negative area would turn to positive area. So we'd have the integral from 0 to 3 of x squared minus 3x dx. And that would give us a negative area, and so we'd have to change the sign of that to make it the positive area. Plus, from 3 to 5, there's some positive areas. So we do the integral from 3 to 5. I don't have to change the sign on this because this area is already positive, of x squared minus 3x dx. So we get minus integral of that is x to the third over 3. Integral of that is minus 3x squared over 2, but we got minus a minus, which makes it plus. We got to evaluate this from 0 to 3 plus. We've got to integrate the same thing, so it's going to be x to the third over 3 minus 3x squared over 2. And we're going to evaluate, I don't have to change the sign on this one, evaluate it from 3 to 5, which is going to be 27 over 3, or minus 9. 3 squared is 9 times 3, 27 over 2. Then when I plug 0 in for these two, I get minus 0. Plus, put 5 in for my x's. And that's 125 over 3. Minus 25 times 3 is 75 over 2. Minus, put 3 in here and I get 27 over 3, or 9. Put 3 in there, I get 27 over 2. This is minus 9 plus 27 over 2. This is minus 9 plus 27 over 2. So that's minus 18 plus 27. Half of 27 plus another half of 27 is 27. Plus 0 plus 125 over 3 minus 75 over 2. Which turns out to be 13 1/6. All right, last page. A lot of you let u be ln of 2x. I would let it be the whole numerator. So I would let u equal ln of 2x plus 1. Then du would be the derivative of ln of 2x. The derivative of ln is 1 over whatever the ln is of, times the derivative of the inside, which is a 2, which a lot of you forgot to do. Derivative of 1 is 0, times dx. So the 2's cancel, and I can multiply both sides by x to cancel that, and I get dx equals x du. So this problem becomes the integral 1/2 in here. 1/2 times 2 is 1. ln of 1 is 0 plus 1 is 1. If I put 2 in here, I get ln of 4 plus 1. Integrated. This is u 3x, and dx is x du. The x's cancel. The integral of u du is u squared over 2, evaluated from 1 to ln 4 plus 1. which I could change back, or I could just plug this in. So I'd have, did I forget my 3? Yes, I did, 1/3. So it becomes 1/6 ln of 4 plus 1 squared. I got the 6 out. Now I'm going to put in 1 minus 1/6. And that's close enough. If you want it in decimal, I believe that comes out to be 0.7824 approximately. This answer would have been fine. Oh, I took the 6 out, so this would be just a 1 in there. Yeah. Okay. Next one. The derivative of secant squared is not tangent, so we shouldn't let u be that. Probably should let it be all of this. So du would equal 4. Derivative of tangent is secant squared x. So dx would be replaced by du over 4 secant squared x. So this becomes the integral. If I put in 0, tangent of 0 is 0, times 4 is 0, minus 7 is negative 7. Pi over 4, tangent of pi over 4 is 1. 1 times 4 is 4, minus 7 is minus 3. Secant squared x u to the third dx is du over 4 secant squared x. The secant squared x's cancel. The 1/4 comes out. So we get 1/4 integral from negative 7 to negative 3 of 1 over u to the third du, which becomes 1/4 integral of u to the third is, that's minus 3. Add 1, it's u to the minus 2 over 2. Evaluated from minus 7 to minus 3, or I could change back to my x's by putting this in for u. I'm working it out, but this will work out to be, this means this goes in the denominator, so it's negative 1/8 and u squared down there. Evaluate from negative 7 to negative 3, which becomes minus 8 times 9 is 72. That's plus, so that's minus. I think I have a minus here. Minus a minus, which is plus, and then minus 7, that's 49 times 8. 50 times 8 is 400 minus 8. No, I'm worried I'm going to make a mistake here. Let's see. Minus 7 squared is 49 times 8. $392, yeah. So minus 1 divided by 7.2 plus 1 divided by 392 is negative 0.011338-ish. If I change that to math, enter, it is 5/441. Okay, the last problem. Well, I got the derivative of y is this, and I want to find out what y is. Determine y, so I've got to integrate this, put the dt over here, and integrate this. The integral of sine with a 4 is just 4 negative cosine 3t plus pi over 2. But if I took the derivative of this, that would be sine. So we'd have 4 times sine, the minus would be gone, and the derivative of that would create a 3 in the denominator. It would create a 3 in the numerator, and there isn't one, so we have to divide by 3 because of that 3 there. Minus and integrate e to the t is e to the t. Plus some constant is what y has got to be. And when t is 0, so if I put 0 in there and 0 in there, I'm supposed to get 2. And e to the 0 is 1, so we got minus 1. And 3 times 0 is 0, plus pi over 2, cosine pi over 2 is 0. So all of this is 0. So if I add 1 to both sides, I get c equals 3. So finally, my equation would be minus 4 cosine 3t plus pi over 2 minus e to the t, and this is over 3, plus c, which is 3, equals the y.